If alpha beta are solutions of the equation a cos theta plus b sin theta equals to c, then show that cos of alpha plus beta is a square minus b square by a square plus b square. Now what is our approach to solve this problem? Let's understand first what we need to find out. That is cos of alpha plus beta, which is given by cos alpha cos beta minus sin alpha sin beta. Now how to get the values of cos alpha cos beta and sin alpha sin beta? For that our process, what we are going to do is we will take that a cos theta plus b sin theta equals to c. We'll try to transform that in terms of cos theta once, in terms of sin theta once. If it is in terms of sin theta, then the solutions will be sin alpha sin beta. If it is in terms of cos theta, then the solutions will be cos alpha cos beta. Then we leverage the relationship between quotients and the roots of a quadratic polynomial, and we'll try to find out what is cos alpha cos beta and sin alpha sin beta. So let's go ahead and write down a cos theta equals to c minus b sin theta. Let us square it on both sides. Why are we doing that? Because we want it to be in terms of sin theta. So cos square theta should be written in terms of sin square theta. Then only we can make it into a quadratic equation in sin theta. So it will become now a square into 1 minus sin square theta equals to c square plus b square sin square theta minus 2bc sin theta. Now let's try to get it into a quadratic form. We will have a square plus b square sin square theta minus 2bc sin theta plus c square minus a square equals to 0. Now we know that the solutions of this quadratic equation will be sin alpha comma sin beta, and the product of the solution, that is roots sin alpha into sin beta, is given by c square minus a square by a square plus b square. Because ax square plus bx plus c equals to 0 is a quadratic equation, then the product of roots is given by c by a. So here we have c square minus a square by a square plus b square. Now once we got sin alpha sin beta, we will take again a cos theta plus b sin theta equals to c. Now this time we will try to transform that in terms of cos theta, so that we can get what is cos alpha cos beta. Now we can solve this problem also using submultiple angles concept, but that will be little bit lengthier. This is the easiest way to solve this. So let's go ahead and try to get a cos theta plus b sin theta equals to c in terms of a quadratic equation in terms of cos theta. For that we will write down b sin theta equals to c minus a cos theta, and we will square it on both sides, because we need to get that sin theta to be converted into cos theta. So we'll have b square sin square theta equals to c square plus a square cos square theta minus 2ac cos theta. Let's try to get everything to left hand side and make it into a quadratic equation in terms of cos theta. So we will have b square into 1 minus cos square theta equals to c square plus a square cos square theta minus 2ac cos theta. In the next step we will try to get this into quadratic equation form. So we will write it as a square plus b square into cos square theta minus 2ac cos theta plus c square minus b square equals to 0. Now we know that the solutions of this quadratic equation are cos alpha comma cos beta. Then product of them, that is cos alpha into cos beta, is given by constant term, that is c square minus b square, divided by quotient of cos square theta, that is a square plus b square. Now we know what is cos alpha cos beta. We also know what is sin alpha sin beta. Easily we can understand that what is cos of alpha plus beta. Cos of alpha plus beta equals to cos alpha cos beta minus sin alpha sin beta, which is nothing but c square minus b square divided by a square plus b square minus of c square minus a square divided by a square plus b square. Let us simplify that. We will have a square minus b square by a square plus b square. Now since I found out what is cos of alpha plus beta, you can apply the formula for cos of alpha minus beta, and you can easily see that cos of alpha minus beta is 2c square minus of a square plus b square divided by a square plus b square.